Okay, so now that we know that the gravitational potential energy is negative G m1 m2 over r, we can explore a couple applications of that. To prove Kepler's third law using Newton's law of gravitation, we said some things about, let's see, we said that the force of gravity needs to be doing the centripetal requirement. So capital G m1 m2 over r squared is mv squared over r. And we can express the speed of circular orbit at radius r. Let's see, so let's multiply both sides by r, so we get that cancellation. Let's cancel the mass of the planet that's orbiting, and this is the mass of, the mass of the planet that's orbiting the sun, I suppose. So v is the square root of g m over r. So that's the speed that we have as we are orbiting the sun. How much total energy do we have in circular orbit? These, geosynchronous satellites, right? How much energy do they have? Well, what is the total energy of orbiting at some radius? And we know the potential is negative G m of the sun, let's say, the mass of the planet over r, whatever the radius is of the orbit from the center of that sun, plus excuse me, 1/2 the mass of the thing that's doing the orbiting, v squared. So we can get rid of the radical and we just have g m over r. G m over r, but there's half. So this is minus a thing plus half that thing again. So minus half g m over r. The fact that the total energy is negative indicates that this is a bound state, that this is a closed system. Whatever's orbiting the sun is going to stay orbiting the sun. It lives in an energy well. In order to pull that object away from the sun, we'd have to dump energy in to get to the potential energy floor. So that negative sign is, significant. The other application we can talk about, I'll let that sit a second. The other application we can talk about is the question of escape speed. What speed do we need to have to get from the surface of the Earth, let's say, to a point outside the influence of Earth's gravity? Suppose that all we're doing is launching vertically up, away from the surface of the Earth. What speed do we need to have? If gravity is the only force acting, then the change in the kinetic energy has to be the negative of the change of the potential. Where it just to get to the edge of everything, our final kinetic energy is going to be 0. And the question is, what is the initial velocity? This is the variable that we want to solve for. Negative delta u. Okay, so u2 at infinity. G negative g m1 m2 over infinity, infinitely far away, minus negative g m1 m2 over, we started on the surface of the Earth. This first term goes to 0 because over infinity. Minus a minus a minus gets us a minus g m1 m2 over r. And let's see, one of these is the Earth, the other is some kind of, mass that's actually traveling. So we've got a minus sign on both sides. We've got a mass on both sides and this factor of 2. So V is, we're going to square root 2 G M E. So we can talk about the escape velocity, the velocity we would need to get to a point such that we are no longer feeling Earth's gravity. Cool deal. Next.